Let's start. Okay. Good morning, all. Welcome to the second session of the data engineering. Um, so we will be talking about ETL since we all have the Databricks Community Edition to learn. So we will be using initially the Databricks platform to do batch processing, some streaming, understand what ETL is, understand what cloud computing is. Then we will talk about various cloud platforms, what they offer, how we do all of that. The cloud processing, data processing on the cloud, um, distributed computing, Apache Spark, and all of that. As I mentioned earlier, we will do a few use cases where community edition does not have features where we will get subscription account for a few use cases. And then we will explore other tools as well on the data engineering apart from Databricks like Snowflake, Kafka, and uh, Azure, right? Airflow. So all of these tools. So let me get into a few concepts and then we will start the batch processing on the on the Databricks or the PySpark. So I'll not go deep into what PySpark is right now, Apache Spark, but once we go through the demo, understand the concepts, we will get deeper into the technical things of how what is Apache Spark and how it does distributed computing, what is a data frame, and all of that. Okay. Uh, so let me share my screen. Okay. So today we're going to talk about, first start with ETL, right? So anybody who want to define what ETL is? Just give me your thoughts. It's a simple concept, right?
Extract, transform, and load.
Yeah. Okay. Extract, transform, and load. Anybody else want to define more about ETL?
So
Okay.
extract is a sense like data is extracted from the various sources. Like uh, it can be extracted from multiple sources, basically. So
Mm.
and it's transformed into a clean and organized way, so that it can be easy for the customers or for us to load them.
यूज
Uh,
होता क्योंकि
uh,
नया है तो भी
Right. Okay. Ishrat, can you unmute, please? Okay. So, yeah, you are right, Rahul. So, ETL is at the basic level, all it does is extract, transform, and load. This is a pretty old, decades old concept, right from the onset of the IT world, right from onset of databases. We have this concept of ETL. Okay. Um, So you extract data, then you do transformations on the data, and then you load it. Basically, you extract from various sources. Initially, there were like databases, different databases, or some files. Then you write. Then you write your programs to do apply business rules on top of that data, and then you load to a data warehouse. This is where when the data warehousing concept came in, where you get all of the data from transactional databases, online, not OLAP, OLTP, right? Online transaction process to online analytical process, OLAP systems. So from OLTP to OLAP systems. Basically your sales data, your revenue, your networking, all of that data you get every day. So you extract all of that data, run some business rules, maybe filter out some data which is not needed, add some description, join with the products or product descriptions, currency conversions. So all of that transformations you do, and then you put it into a data warehouse. What happens on the data warehouses? You basically run through that for reporting purposes to analyze the data, aggregate the data, and then generate reports out of it. That was traditionally the goal of an ETL system. Okay, so what exactly does ETL do, right? So from here you can see basically why we are starting with ETL is the concept, the underlying concept has not changed. So if you look at this, you understand this is going to be the underlying same core concept. Okay, so all of this content is sourced from the ETL tool called Click. We have Click View as Click View. It has BI as well, business and the ETL processing. So if you look at this picture on the left side, as Rahul has mentioned, we have all the databases. Sorry, not databases, all the sources. Okay, so your source can be a SQL database like Oracle, MySQL, SQL Server, whatever it is. Can be a NoSQL database like Cassandra, MongoDB, any other NoSQL, Couchbase, any other NoSQL databases. Then it can be a SaaS platform, something like your Salesforce or Workday, something like that. So all of these SaaS platforms that give you data, XML files, or JSON files or text files, whatever it is, any file. So these are files. So the source can be any of these data sources. Then you extract the data and put it in a staging area and then transform the data there. So their staging area and transformation is the same. Here you can do transformation in flight when you extract it in memory and then do transformation, or you extract and put in staging area and run your transformations on that area. Okay, so this will evolve. This we will see how it goes when we talk about the medallion architecture, what we call the modern ETL built on. Then you load it into a data warehouse. Once you do transformations, you load it into data warehouse. So data warehouse specifically has all of these data combined and again aggregated or separated based on the business requirements. Okay, so you can have monthly data in a different schema, countrywide in different schemas, or you build shards in the databases for faster access of data. So these are huge databases which are optimized for memory, optimized for access. So these were earlier days, data warehousing. Once you do that, then you analyze and generate views for the BI. Okay, so BI tools here like Tableau or Power BI. So any of those Click View. So any of those analytics dashboards basically were built on those data warehouses. So this is the basic concept of ETL. Okay, so remember this. We will come back to this when we talk about the medallion architecture, how it relates to this initial ETL foundation, right? So we will compare and contrast between these two architectures. It's good. Any questions, guys? You know what ETL is? We will talk more about why we have to do ETL. Examples, use cases. Then we will move on to the other stuff. Okay. Are we good? Can you move forward?
Yes, sir. Yeah.
So what are the ETL use cases? So ETL process helps eliminate data errors, bottlenecks, latency to provide for smooth flow of data from one system to the other. So key use cases, migrating data from legacy system to a new repository. Okay, suppose we have a legacy system, old system like data frames, DB2, whatever, which we are now modernizing into a new, say for example, cloud database. Okay, so data is still coming in. We have not changed the legacy application systems where applications are writing into the legacy database or whatever. So from there, we take the data and migrate to the cloud platform. It can be one time, or then you can have daily data, delta data that is coming in on a daily basis. You take that data and then put it into the cloud database so that we have all the data in the cloud or all the data in a modern database platform. Okay. Then centralizing data sources to get consolidated version of the data. So like we said, the data is coming from multiple sources, but then you can have all of the data consolidated in at one place. So you get, say for example, your country is in 4 or 5, your business is in 4 or 5 countries. Each country is sending you a different format. Okay. So US, you have data in database, in a SQL database. Europe, they have something MongoDB, or Australia, they are sending only files. They are not sending any you don't have connection to that database. They just want to send the files. Now if you want to have an aggregated view of all of your revenue or sales, whatever, across all the countries, then you have to get all of the data, consolidate, get it into a common format and put it at one place to do the aggregations. Enriching data in one system with data from another system. So customer data, for example, when you do a sales from one place, in a point of sale, you may not get the complete information of the customer, but you may have another CRM system, customer relationship management, where you have all the information of the customer. Then you can join these two when you do ETL and enrich that information. Or the customer has changed phone number or address, which is provided at the point of sale, but we want to update it to the CRM system. That's the main. So when we go to any of the service, right? So they ask you, are you still at this address, or is this the correct address? Then you say, no, I have changed the address. They take the new address, but then the central repository still reflects the old address. So how do you rectify that? So when you do a kind of upload or ETL process, then it gets into consolidated view. Then you say, hey, there is a new address that's come in. Then you get update your data, comparing your old address and the new address. If it's changed, then you update. Then providing stable data for data analytics. You want to do analytics on your data, to do machine learning or prediction or whatever, to do, what is my sales projections, revenue projections based on the historical data. So all of that analysis that you want to do, you have to have data from all the systems, but you have to have clean data and in a common format, and you have to have good data all at one place. Okay, you cannot run analytics on 5 different data sources on 5 different formats and then combine all of that. That's too unproductive. And you have complying with GDPR, HIPAA, and CCPA standards. So these are some of the regulatory requirements for companies. So HIPAA is mainly for health insurance. Health Insurance Protection Act. CCA is customers and general data protection. GDPR, which is European. This is California customers. So there are some regulations for some of the industries where you have to comply with those regulations. It's a pretty serious matter for the companies. If they don't follow that, people might sue you for their information being compromised or being available openly. So and then the government can also take action on the companies. So these are the very serious regulatory requirements that all the companies have to follow. Some of them, there are many more. SOX compliance, security compliance, there are a lot of other things. So for the companies to comply with that, there are so many tools. I mean, ETL is one process that will help. But again, when you go deeper into Databricks also, It tells you how you implement your processes to comply with these regulations. Basically, if you want to delete data, you want to mask data, personal information like SSN, or names, date of birth. So you have to mask that data so that it is not freely available to everybody, or have access control. So only who can see that data. HR admin can only HR admin can see the person data, right? Developers cannot see all the data, should not see all the data. So you have to have that access, and also you also have what kind of data when she see in the front end, whether you have to mask that data. And if they want to delete, for example, you have customer options, marketing options. So they keep sending you the spam emails or promotion emails, and you have opted out. Okay. So once you have opted out, it's a serious, you have a window like 7 days or something, after within which they have to comply with, say, remove this customer does not want to remove promotional emails from us. So they have to remove those, um, remove that check mark or the customer options. So they have to save. And then it should, who sends the marketing promotion? It's the marketing department or some kind of a marketing campaign that's they run. So that can be a third party vendor, that can be a different system altogether. Okay. And the options you select may go to CRM system somewhere, right? So it has to flow all the way from there to all the database customer repository, and from there you have to join with the marketing data, send it to third party. They have to take it, process and exclude these customers from their mails within after a week. So even after a week, you still keep getting the promotional emails. Then you can complain against the company, right? So that's a serious thing. So if they say remove me from all of your databases, I don't want you to store my information. So you have to delete all the data of the customer from your systems. Of course, historical data like orders and all you can still keep, or if they don't want, you can remove those data. So all that systems, again, it has to flow from end to end, right? And how do you do this? You have to consolidate all the data, make sure it is flowing through all the systems, where ETL also helps you in doing all of that process. Okay, you with me?
Yeah.
Okay. So what are the use cases for ETL? So global retailer, like say Walmart or Amazon, they integrate data from multiple sources, right? So Walmart, you can go to store, point of sale, POS, you can buy something there, you can do online, okay? So they have to integrate all of these systems wherever they're getting the information, sales data or customer data from. So it will help unify these data streams to ensure accurate stock management. Somebody is buying online, somebody is buying in stores, somebody is buying from a third party. So you have to accurately see how many items are sold, online per day, per hour. If there is a hot item, that's new item that it's selling very hot, and it's out of stock, you should immediately reflect it on your online or in the store that we don't have any more items, right? So how, if you just keep track of one, only online, and if you don't keep track of how many were sold in the point of sale, then you have inaccurate data that you will be putting in. So banking and financials, so like JPMC, need to aggregate customer transaction from multiple accounts, detect fraud activity, generate compliance reports. So this is an example. So this enables real-time fraud detection. So where you get transactions from different sources. Again, you combine all of that, streaming live data, regulatory compliance, customer risk. So all of that. Healthcare and life sciences, to integrate patient records from EHR, electronic health records. Your patient data can be from EHR. Your data can be from lab results where you go and give, for the lab. You can give your data to insurance claims. You can go to urgent care. You can go to different network of the hospital. It may have different networks. So all of that data from the doctors. So all of that you can combine for the patient to get a holistic view of the patient. It helps data quality, maintain again Health Insurance Protection Act HIPAA compliance, and enables predictive analytics for better patient care and treatment recommendations. So based on the patient history, if you have all at one place, you can track and easily see what's happening with the patient and provide better care for that. So similarly, you have telecom where they do customer churn analysis, fraud detection, who's about to leave. They give more offers to the customers if they're happening any fraud detection, optimizing network. Car manufacturing like Tesla or Ford integrate from IoT sensors, factory equipment, supply chain, and logistics. So IoT sensors, remember, so when you're driving, each data point is sent back to the server. Okay, how you are driving, what is your pattern, how much speed you go at different places, and they map the road you're taking. Are there the roads are blocked, or you're taking a diversion? What are your preferences? How are you driving? Are you crossing lanes? So all of that data is your driving behavior, to analyze your driving behavior, and your insurance is attached to your driving behavior, both the number of miles that you drive and how you drive, the driving behavior. It says what is the speed limit and how much speed you're going in. So all of this data is continuously being monitored and then processed for you. One, to better give you better services, plus to also helps the companies to track the behavior of the customers. Media, Netflix, Spotify, user activity logs, watch, listen, history, content, metadata. Again, Netflix use the most famous is the recommendation engine, like Amazon also, based on your past history, or based on your browsing history, based on your items you have searched for, items you have bought in the past. They're going to suggest you the new items, right? So how does it happen? It's all like machine learning based on your activity. So each of your activity uh, is stored, right? Is captured and then sent to the databases, and then sent to the systems to analyze and do predictive analytics, apply machine learning. So hey, this customer has bought this item, so he is most likely to be interested to buy in these items. So those are all related items that that they show you. Okay. uh, Something similar Netflix. So if you are more interested in rom-coms, or in more interested in sci-fi or historical war movies, so because you have watched this, we think you will be interested in these movies. So that's again your kind of machine learning and AI that is in action, based on your actions, based on your history. So even if you're watching, even if you have a machine learning algorithm that can tell you, but ML or AI cannot help if the data is not given to them, right? So they need data to work on. So without data, none of the machine learning, AI, whatever is useless. And again, the quality of the data is more important, not just the data. So if you put junk data, you get junk output. If you put biased data, you get biased output. Okay, so the data has to be there, and it should be good quality data. Okay, if I give data, I'll say 100 customers, hey, here is the data for 100 customers, but I just have the first name, last name. So let's say date of birth I give you, SSN I give you, okay, address I give you, but I don't give him what movies I watched. And then I feed it and tell him what would I recommend to these customers. Would it be able to do it? No, right? You have given it data, but it's not a good quality. There is no information for the history of or interest of that customer. So basically, you need to have data, plus you need to have quality data. good quality data. And plus, you need to have enough information. So if I say this customer has to one movie, so suggest him few movies. So you can, but it's not enough data to see a pattern. Okay. So if I give, that's called bias. So if I give him only the war movies that I have watched, say I have watched 2 or 3 war movies. So the system will think I only like war movies. I may have watched other movies also, which I like, sci-fi movies or comedy movies. But unless you share all of the data, the system is biased, right? Because you have given the data, biased data. You only given one particular data to the system. So that's what it thinks, that's what it works, and that's what it comes out. So it will only recommend you war movies, no other movies. So basically, so all of this, the data is the most important component of all these systems, whether ETL, data engineering, machine learning, deep learning, NLP, natural language processing, Gen AI, whatever it is. The core is data. Without data, none of these systems work. None of these systems give you, better output, anticipated output, or good quality output. Okay. Any questions? Yeah, I don't have enough, so just the last slide. We talk about a few things and then we jump onto it. So what are the different types of ETL tools? We can do batch processing, which is primary ETL process, as I said. Batch processing, right from the decades. If you remember, people who have 10 plus 15 years of experience, all the batches used to run at night, because that time the traffic is less, network is less. So you get more bandwidth and your jobs run faster and the systems will be faster. So organizations computing power, because at that time everything is on prem, the servers are all, every company used to have their own server room, maintenance, and they have limited computing power that you need to share. So if you run the jobs in the middle of the day, the business customers or the users will get impacted. So they used to run all batches at night after 6 p.m., after 7 p.m. until 4 a.m., 5 a.m. kind of thing. So that is batch, and you schedule your jobs. Hey, this job runs at 11. You see what other jobs are running at that time in monitor and see how many jobs you can run in parallel. What is the volume of data it is processing from there? So then you schedule how long does this take to run? Do we need to run multiple times or one time? Do we need to run? All of those things were planned to schedule the jobs. So from that, then we became cloud native. So jobs, all of them were like, then we got these cloud, Amazon, Azure, Google Cloud. So cloud native ETL tools, they can extract and load data from sources directly into cloud data warehouse. So you can have your database on the cloud itself. So Postgres database, if you want, you can have on AWS. Cosmos database you can have on Azure. You can store data in Snowflake. You can store data in Google BigQuery, Bigtable, whatever. So you can store data in the Databricks platform, Databricks Delta. So all of this you can do on the cloud. Now you can use the cloud power right now. So resources are unlimited in the sense availability, but again, you have to pay for that. But you don't have to worry about resources being shared. So if you want to run a bad job, you can run every half an hour, every 1 hour. It will have its own resources and charged for its own resources. And your customer business, everything can go on parallelly without being impacted. That they are not shared anymore. Then open source tools like Kafka and commercial tools. So for streaming, so Kafka also can, you put ingest data from different sources, and the Kafka has a retention period. You can put there and then you can process them, or you can process them, in the live stream. As and when the data is coming into Kafka, you can start reading the data from Kafka and then process and put it into the databases. So this is more like real time. Today's business demands real time access to data. It's like the transaction has happened. You have already, it's there in the system. You have done the ETL, you have done the processing. It's there in the BI visible. So end to end, in minutes or in seconds, near real time access to data. That's what is now we are able to achieve using the cloud platforms, hyperscalers, and all of that. Specifically, it is needed with a distributed model and streaming. So most critical or important use case for this is the credit card transactions. So when you just tap your credit card, within the seconds, it'll tell, if it is a fraudulent, it'll flag immediately. Okay, sometimes they block you, to let them know, is it you that you are using your card. So how does it happen? It's online, right? It's not like you did the transaction, they stored it, then they run the batch process, then the data goes in, they process it, then they compare with the previous transactions, apply the algorithm. So all of that, if you do post, by that time the transaction has already happened and fraud has already happened. So what happens the moment you tap, it's live. The live transaction goes in, it goes directly to the streaming systems. They automatically run the ML or algorithm online to see the pattern of this transaction, what is happening, where is it happening, is it right parameters that have come in, is it a fraud or good enough transaction, and then they let it allow. So that is the real-time ETL, that real-time access to data that systems need these days. Okay, that's where all of these systems and power is being used. Okay, so that brings us to enough theory or concepts of ETL, and then we will get into the demo part. So you have any questions before going? So we are all clear what ETL, why ETL. Basically, what we are doing data engineering, but why are we going into ETL, right? So you're clear of why, because ETL is the foundational concept. Okay, no matter how the different flavors or terminology we use, we keep inventing the beautiful terminology, beautiful words, but the process underlying is still the same. So you call ETL, then the new term is ELT. So instead of extract, transform, and load, they do ELT, extract, load, and then transform the data. And it's a loop kind of a thing, right? So that's another concept. What is ETL? What is ELT? Which one is better? Okay. We have data engineering. What does data engineering do basically? Data engineering also build data pipelines, just like ETL pipelines. You have data pipelines, right? So your tools have evolved. Earlier, you used to write programs in Java or C or C++ or whatever language, .NET or whatever, Java, to create JDBC connectors to connect to the database, pull the data, write cursors, PL SQL, all of that. And for each record, you do transformations, you write transformations, thousands of, hundreds of thousands of lines of code. It evolved, then we came systems like Pentahole, systems like Informatica, Talent, ETL tools, where it is visual, drag and drop. So you drag and drop a source widget, and then you configure. You give it a source name, you give it a connector, whether it is, what is the type, it is JDBC. So it is already has JDBC connectors, it will automatically, you just need to provide the parameters. Okay, like what you call, what is the host, port, username, password, database, schema, table. So it will automatically pull the data. Okay. And then for transformations, you have special widgets. What do you want to aggregate? Do you want to sum? Do you want to transform the data? Do you want to look up the data, master data? So everything is UI and drag and drop and minimum code that you do. And right. So that is evolution of the ETL things. Now, what we are doing data engineering, we are doing data pipelines. So basically, you are also going back to the same thing, right? You still do the same kind of ETL. There might be few more modern advanced techniques and concepts that you use, maybe because now you use distributed computing, we use cloud processing, cloud platforms, cloud storage, and all of that. Okay, that's why we still need kind of these things. Okay, are you guys all clear? Everybody with me? Any questions?
Yeah, Harun, so I have a question. So you explained on batch processing, right? What are the various tools uh, we use for batch processing in big data environment? Is that anything different from big data environment to other environment where actually where cloud environment is not set up? So any differences there? What tools we go
So,
for?
yeah, that's a good question. So, any of the tools you can use both for batch processing or stream processing. Okay. If you have, for example, Kafka, or you have Informatica, or you have Databricks, you can use all of this to do. So, Informatica, you can actually, you can do scheduling, not live. So, you schedule the entire Informatica pipeline. Say I want to run this pipeline Informatica job every 1 hour or every 3 hours or every 6 hours, whatever like that. So same thing, Databricks also, you create a pipeline, you create a job, you can schedule it to run batch every 1 hour, 3 hours, 6 hours. Or you can create a live, same Databricks, you can create streaming and then put it synchronous, it will keep running. Okay. The same, the beauty of the Databricks is you can use the same pipeline both for batch as well as streaming. If you want to schedule it as batch, you can schedule it batch. If you want to do streaming, you just have to redefine your reading spark.read, whatever you read from, as a stream. Or you can use Delta Live tables, which are like again live streaming. So Kafka also, you get data. There is retention period. You can put 3 days, 7 days, whatever. Kafka keeps that data. You can connect to Kafka in batch mode every, say 3 hours or 10 hours, whatever, daily, twice or thrice daily, and you can read the data. Or you can keep running some application live, like Spark again streaming, and it keeps reading in micro batches from Kafka. So you're reading every minute or every second, for the time interval. So every 30 seconds, if you put, it goes every 30 seconds, checks what is the new data that has arrived, take that batch and process it. Then again, 30 seconds, it goes back and checks. So it is live kind of thing. So basically, most of the tools, whatever tool you use, you can use for it. It does not depend on whether it is cloud or on-prem, but it will tell you some of the tools which support the streaming, like Databricks, like Kafka, like which support the streaming data. Kinesis, you have. And there's one more. So all of these tools that you can use for streaming live. So streaming is basically your batches running more and more often. Okay, from daily to twice a day or hourly. Then you run every half hour or you run every 1 minute. If you keep moving it much shorter intervals between the runs, it gets more closer to near real time. Say in real time is just a batch which is running every 1 second, kind of. It's called micro batching. That's how the Databricks runs, right? So that's the live. Again, it depends on the use cases. Do I still need live data, live use cases to run, or do I just need the batch process? I am okay with waiting for 1 hour for the data. Okay, or
That is
I'm okay.
scheduled.
Yeah,
Schedule
schedule.
jobs. Schedule
Yes.
jobs. Okay.
Yeah.
But
So I'm
real-time job,
okay
as
with
you said,
getting.
yeah.
Yeah. So I'm okay. Let's say, for example, Costco. It has gas selling in 7, 8 countries. Do I need streaming data, live data as and when customer buys gas? No, I need only the sales on that day for that particular store. So every country will send their end of day data in a file. And then I run my integration maybe once a day, or maybe once a day may not be good enough, because the day starts in US separately, the day starts in Australia separately. So you might miss out a complete day. So what you do, you make sure to run 2 or 3 times a day so that you meet the time zone of every country, right? So next day morning US, you have all the data from all the countries. If you are running 2, 3 times a day. So that's how you decide how much data I want to look at the aggregation kind of thing.
Okay.
Okay. All right. So let's come back here. So this is everybody has the Databricks community edition, right? So here I have created a folder. So before that, first I will go and create, I'll show you compute. Okay. So what is a compute? I know this. Okay. So compute, you cannot restart on community. So you have to create, this is disabled only on the paid accounts. It is enabled. You can restart. So what is the compute is for any job you run, for any process you run, for any notebook you run, anything you want to run, you need to have some server or some machine to run your job because it's running on the cloud. It's not running on your laptop, right? So to get that, you have to create a cluster, compute cluster. Compute cluster means just a group of machines or a number of machines that work together to share the load when you run your job. So we will come to it when we talk about the architecture, the master and slave or the master and worker architecture, that how your cluster is, okay, that you can create. Because it's a free, you get only one machine when you create a cluster to run your job. So compute, you can go and say, I want to create a compute, a machine to run my programs. That's it. That's a simple term as of now. Okay. This, so let's say I want to I want to rename compute 020225. Okay. So once you create this compute, you can attach this to run any of my programs. For now, just remember that. Then we will talk about what are the options, what you need, how much power you need, how you want to create this. So this will give you a runtime, just like you must have, what is the runtime, Databricks runtime version 12.2. It is built on Scala 212, Spark 332 versions. Okay, these are the languages that it supports, this compute. Don't worry too much about it right now. We're just creating some processing power, some processing engine that you can use to run your job. So come here and say create compute. Okay, so this will create this compute and we will come here to use that. So meanwhile, while that is creating, I'm going to go here. This is the folder I have created in the workspace, data engineering. So here I will go. Yesterday we talked about, we have a clone, we have create, I can create a notebook or I can import. So when I import, I can have a URL. So I have a notebook that I published. I will show you what published means, how you can import. But remember, this is how you import the notebook. Go back, go to the folder, go to import, file or URL, go to URL, and here paste the URL I will give you when I publish this notebook and say import. So this will give you the complete notebook. Okay. It will be imported to your environment, your account. There's a picture here. Forgot to get this. You have to add. Let me just go to the picture once. That is in the separate account. Then we can come back here. It's the Sure. Mm. Okay. So so I have to export this link here. Basically, this image is not available, so it's not displaying. So I'll tell you how to add that image here, because it says that image has to be placed in this folder here. Then it will pick up and show you that image. Okay. For now, we can refer. It's the same image here. We can talk about this. So remember how we are doing ETL. So in the Databricks world, the same thing, you have what we call as medallion architecture. Okay. Like medals that you give, right? Bronze, silver, and gold medals in sports. The highest is gold, then silver, then bronze. This is same as we progress with the quality of the data and aggregation of the data. So same as in ETL, you extract data. So again, here also you have sources, files, databases, streaming. Then you have a raw layer. So where you just dump as is whatever data that is coming in. So this is your source of truth. It's like this layer is as close to the source as possible. So bronze layer is same as your source data, which is your raw data. Then you run your jobs. So basically the same job you can run. First put it here, some tables you create and dump into raw data. Then you create some tables in silver, read the data from here, do some transactions, process transformations, and then write it to silver. From here, again, you take the data, do aggregations. Okay. So business level model aggregations that you do, and then you put it in the gold layer. So whatever is your BI analysis, reporting, the data science, machine learning, or BI, Tableau, whatever business intelligence dashboards, reports that you generate, or ML programs that you run will take the data from the gold layer. Maybe data science ML may need more detailed data more than aggregation, so they can read from silver as well. But this analysis and reporting, they run from the gold layer. So this is the as and when you improve the data quality, your layers change, bronze, silver, and gold. This is called the medallion architecture, which most of the companies adopt when they run their data engineering pipelines. But this is not hard and fast rule. Some companies may skip the silver layer. Some companies may skip the bronze. I don't need to store raw data. I just read in memory, I transform and write it to silver. So anything is fine, but this is the recommended or most adapted model for the this architecture. Okay, so keep in mind medallion architecture. You have to talk about it everywhere you talk about the data engineering. Okay. Now, so I'm doing my compute. So what I did again is I have a source file. Okay, I've taken a source file which I want to ingest and do some transformations. Right. So let's say I have this customer sample CSV files, customers 100, which is my, where is this? So here, customers 100, edit with notepad. Okay, so this is my customers file. So where I have index, customer ID, first name, last name, company, city. Okay, this is customers 100. I think this is what we did yesterday. 1 second, let me see what we did today. Right. All right. Let me go here. And see, there is a file store tables yesterday, remember, and the folder Harun. We have some of the data that we have put it here. So this takes, oh, there is no cluster here. So let me compute. So basically we have this files, which is called movies, ratings, tags, and links that I will give you where to download from Kaggle, this entire data set. Once you download it, you will have all of these files. So these files we will use to run the jobs from different, from files to tables and all of that. So if you run this file store table / movie lens folder, it tells me I have all of these files. It has the readme, links, CSV, movies, CSV, ratings, and tag CSV. So this is just like in your Windows or in Unix, you want to list the files that you have. The same thing, Databricks also has a file store that it stores these files where we upload the files, right? So remember yesterday, I have shown you, if you go here, new, you just go to table, and here you can upload your files, folder name, and then upload the files here, right? So then those files are stored in that folder, which you can go and check using your utility, like list the files in the directory. Okay, so these are all the files. Now I'm taking one file, movies.csv. So this is the file location. So wherever it has, in this I have stored. Let me run. Once I get the compute, we will run and see. Now let's see where we have the files. Do we have here? Okay. So here we have this PNG file and movies.csv also. Then there is another folder called movie lens folder. So here I see links, movies, ratings, and tags. There are 4 files here. And then there is another folder starbricks.2 there where I have movies.csv. There are multiple locations, based on recent. You can just put it at this path and use this path. That's fine. So there is a path movies.csv. This is the name and this is size. Okay. Now, yesterday we looked at how we are doing the ETL, right? So first what we do, we read this file called movies.csv. Infer schema is true, which means what is the schema basically? What are my columns in the table, right? So that is my schema. So what I will do, I will let Databricks to check the file, scan it, and see what is the schema that it needs. What are all the columns and what are all the data types for those columns? Is it a number? Is it a string? Is it a decimal? Is it a date? So I will let Databricks to do that. We can also create our own schema and provide that we will do. Initially, we will give it option to decide what schema it has looking at the file. Normally in production, in the standard data pipelines, you never give this true. You always want to enforce your schema. Otherwise, if the schema is different from the file and what you are expecting, you would just reject the file and raise a alert saying that we got a bad file or the schema does not match. So that's what happens in the actual process in the production when you write the pipelines. Has header true. So these are all the options. So we say the file already has a header, use that as your column name. And then we say we are creating a data frame, spark.read. Spark.read will simply read the file based on your options and path you provide. So format, file type, what is the file type? CSV. Schema, infer schema is true. Okay. Separation is comma delimiter. The file is comma delimited. Option header has header. So this is the options that we gave, and we gave the file location. So that will read the file, and then we are displaying to see what we have in the file. So let's run this. When it run, and I run this, you can see here it's running. Then when it's completed, it will display the data here. So what are all the columns? Movie ID, title, genres. Okay. So I think I should have movie lens. 1 second. Let me also see where that I have. Yes. So I will just go and say movie lens, Kaggle dataset. I'll get you the dataset from where I have downloaded. Need to check that. I'll give you the link to the dataset. You can download that. But yeah, okay. So let's come back here. So this is the data. It has movie ID, it has title, and again within the title, it has the year when it was released. Okay. Genres, it falls into multiple genres. Let's say you have adventure, animation, children, comedy. So all of that, it falls under different genres. This Grumpier Old Man, it falls in two genres, comedy, romance. Father of the Bride just falls, it's just a comedy movie. So basically, like you have action, you have horror comedy, you have action, you have rom-com. So all of those genres. So basically it has these three columns. And this is the sample data that we got. Now, all of this data is in this movie's data frame. So what is a data frame? We will come to it. So a data frame is just a tabular representation of data in memory. Okay. So this is represented tabular data of whatever it has read from the file. It is represented in a tabular format with columns. It has a schema. It has columns, data type, and data, everything. It's just like a database table in memory. You can do SQL queries. You can do, what you call PySpark, Python related data frame related queries that you can write in PySpark, or you can write SQL queries in the format. So what you can do here again is you can do, say, I have same three columns. Now I am creating my own structure. Okay, struct field, integer type, string type. So these are all standard types that you can import. So I am telling the program, the pipeline, that the column movie ID, there will be a column called movie ID, and it will be integer type. There will be column called title, it will be string. There will be column called genres, it will be string. Now, when I read the CSV, this is another way of reading it. You can give like this, all of these options, or you can use this format, say read.csv. Here you are giving directly the format. You are directly giving the path. You are giving a separator. You are saying header true. Options directly you can give. And schema, you are passing this schema object. What is the schema object? Is a struct type object of an array which has struct fields. Each field is a struct field. As and when you have more fields, you can just keep adding to this struct type, which has struct fields. Okay. So each field will have a name of the column, type, and this true means whether that column can be null or not null. Okay. So if you say true, it can be null, which means if that there is no data in that, it will still accept for some of the records. But if you say the ID is definitely or title should not be null. So I will keep this false. If you get the file data with this, it will throw error saying that there is no title provided for this record. So it will reject that. And then you pass that schema here. And then you can say display this data frame. So when you read using these options, how does it display? So you're just run this. So this is the data. Again, same data. There's no change. Earlier, you let the program decide the schema. Now you are providing the schema as well. Okay. All right. Guys, are you with me? There's absolute silence. I'm worried. Are you following? Or is it?
Yes. Yes.
Yeah,
Sir.
yes.
Are we all good? I'm sensing low energy. Are you distracted, bored? Are you getting the concept?
Yeah,
Yeah. Trying to understand the concept.
Ramya?
Yeah. Understanding the concept.
Rahul?
Yes, sir. Yeah.
You're good. Anirudh?
Yes, sir.
You're able to follow, right?
Yeah.
Okay. All right. Anshu, you're good?
Yes, sir.
Okay. Nice. Okay. So yeah, this will be first, class. We will be running these kind of reading and writing multiple times. So over the time, it will become very easy. So first time it looks daunting, but we are not doing very complex thing here. Okay. All we are doing is there is a file, a CSV file, and then we are reading the file and displaying the data here. That's it. How we are reading it? Simple. You can go here. This is you're giving all of these options and saying Spark dot read and then this thing, or you can go here, create your own schema and then do this. Okay, so that is also fine. Now, what we said, we want to create databases. Okay, bronze, silver, and gold, just like medallion architecture. Right here, I have a medallion architecture: bronze, silver, and gold. Now, if I go here in catalog, default, I see there are no tables. Okay, and it's just the default. No databases, no tables. So what I go back here and I will create those tables. No, sorry, databases first. See here, see, I'm using SQL now to create the database. So this is a SQL widget. So I can go run this. It's run. Okay. Now let's go back to the catalog and see here, bronze, gold, silver. Now all three databases are created, right? But there are still no tables in any of this. Now, what is the first step in ETL? In medallion architecture, what do we do?
Extract.
Yeah, extract and then do what? What is the first layer in the medallion? What are the medals?
Transform and load.
No, that is ETL. We are now talking about medallion. What are the medals? What medals?
Gold.
Bronze. Yeah,
Gold,
and
silver.
Bronze.
Bronze, yes. So the first one is bronze. So when you read the data, you first put into the bronze layer, correct? So that is the raw data. You can call raw, you can call bronze. Again, don't stick to the names. This is just bronze, gold, silver. Tomorrow you can say raw layer, raw, transformed, and final. You can name anything. Okay, you can just say layer 1, layer 2, layer 3. It doesn't matter. It's just conceptual. Medallion architecture is only conceptual. There is no limitation or mandation that it has to be called bronze. Okay, most of the companies don't call it bronze. They can have their own nomenclature. Okay, you can say raw transformed final, raw transformed gold, raw silver, so whatever, bronze transformed data, whatever you can call. Okay, so keep a mental note of that so that you don't go and see always bronze, silver, and gold. It can be anything. Now, in the bronze database, I'm creating a table called movies. Okay, I want my table name as movies in the bronze. Now, movies data frame. What is my movies data frame? When we go back and see what is movies data frame, this is my movies data frame, correct? What does it has data from? This file, movies.csv. So what is that data? This one, movie ID, title, genres, right? So this is what we have data here. Now this movies data frame, I want to write into the table. Now this is in memory. The data frame is in memory. Now I want to write it to the database, to persist to the database. Again, this database is in the Databricks. We are not using any external database like MySQL, MongoDB, Postgres, Redshift. We are not Snowflake. We are not using any external database. This is all in the Databricks layer. So Databricks has its own data storage called Delta. We will talk about it when we talk about the Databricks architecture. But for now, understand this databases are still in the Databricks architecture, in the Databricks environment. So in the bronze database, I want my table to be movies. I take this movies data frame, which is in memory, my data, and then I want to write it in what format? Delta. So this is a Databricks format. called delta. So I'm using the delta format. Mode is override. So mode, you can have multiple modes here, like append, override. So there are different SCD type 1, type 2 when you use. So you can have append, just keep adding the data to the table, or you can overwrite. Overwrite means the previous data is all deleted and the new data is added. It's kind of truncate and load, kind of full load kind of a thing. Option. Then I'm saying save as a table. What is the table name? Bronze.movies. So if you are very getting confused with this, just comment out this part. Take this name. Put it here. Okay. So data frame, write it in the format delta. Mode is overwrite, truncate everything and write. And this is the name. This is the database. This is the table, or this is, you can call schema. And this is the table, bronze.movies. So when I run this, now the table is not there. So it will go ahead and create the table and then write the data in that table. Simple. Okay. So now what all transactions or processing we have done till now? Can you list? Till this point to get the data into the table, what all transaction, how many transactions or how many operations we have done?
We have read.
Yeah, one of you, anybody. Anshu, you can go ahead.
We have read the data and load the data.
Okay, so we have read the data from the file. We have
From the
created
file.
the schema.
Schema and table and database and table, and then we
table,
have
then write to the
writing the
table.
data.
All of this we have done. How many lines of code we have written?
Mostly
We have just written 2 lines of code.
2 lines. Okay. Yeah.
2 lines. One to read, one to write. That's it. I mean, rest of all is like boilerplate, or you don't do this every time, right? So this will already be there. You don't do this. Okay, let's say we have struct type. This is again definition. It's not a code. We are just defining the structure, okay, of the file. The actual job that runs or the code that runs is only this, right? You're just reading the file. Or let's say we have not done this. We have run this, right? So there is only one line of code, movies.df equal to spark.read. And these are all options. So we just put one line to read, and then we jump here. And then we put one line to write. That's it. In 2 lines of code, the entire data of the file is moved to the database. And remember, it doesn't matter the file is 100 records, 1000 records, a million records. Okay, it will still be 2 lines of code. There are companies who have moved GBs, or half a TB of data, 100 GB, 500 GB of data from source with transformations to the aggregation layer with 20 lines of code. Just 20 lines, they were able to move 200 GB, 500 GB of data, transform data into the target database with just 20 lines of code. Remember the power of the latest data engineering. So that's the power. That's why it is more popular, not because something fancy or something new invented. It's just sheer simplicity of writing the programs and the power of running them, the processing power. Of course, we only have a small cluster here, but then you can choose. If I have 200 GB of data, if I want to run it 5 minutes, I can run it in 5 minutes. If I want to run in 1 hour, I can run it in 1 hour. Okay. Then based on how fast I want the data, I can choose my processing power. I want a 10 machine cluster. I want a 100 machine cluster. Okay. Or I want a just 2 machine cluster. I have a lot of time. I'm not worried. Let it take 2 hours, 3 hours, let it run. That is also possible. And then I can also choose, hey, I don't want to make any option to select any of the machines. You take care of how many machines you need, how much power you need, how much memory you need, all of that. Just do this task for me. So you leave it everything to the vendor, to Databricks. It will automatically check what is the volume, what is the complexity of the transformations, what are the joins you are doing, how much data it will be, it has to put in the memory, how much memory it needs, everything it will calculate and it will run. That option you choose is called serverless. So these days, this is becoming more popular using serverless. So all that complexity is also taken away from you. You focus on the business. Don't focus on writing thousands of lines of code. Don't focus on scratching your head how much power I need, how many machines I need, how much memory I need. Will I get over out of memory error? Will I get data spill to disk error? Whatever it is. So all of that we will take care of it. You focus on the business, solving the business problem. That should be the only agenda. What transformations do I need to write? Where is my data? How much is my data? What is the best tool I should use to ingest? How best I want to write that code to solve that problem. That's it. So rest of all, as much as possible, the platform will take care of it, right? So now writing from thousands of lines of code to connect, to read the, once you read the file, what you do, you first have is to define a cursor, you have to write a loop, and within that loop, you have to traverse through each column, each field, then apply your things, then read, then write each row by row to the table. Then you have a issue of commit, non-commit. What is your commit size? I want to commit for every 100 records, 1000 records. Is it a batch commit or is it a record commit? So all of those things were there. Now nothing. Everything is taken care of. Just 2 lines of code. You're right. So now see here. Once you have written to the table, movies, now you go here, say in the bronze layer, the movies table is created. I am getting too bug here. Catalog. Let me just. Catalog. Okay, so you can see the schema that it has created for the table, and you can also see the sample data in the table. So now this is persisted to the database. Now it is in the database. Now I can go here to my notebook where I'm doing. Now I come here. So here, this is SQL now. Okay, I'm getting data from the database. So now I do select star from bronze.movies. So you get the data from the database. Okay, so you can write any SQL here. You can do select count star, run 9,742. Okay, you can say just I want to write, just select title. I can do select title, just title. Okay, so You can do your SQL on the database directly from here in the notebook using %SQL. Now I want to see table display type movies. Oh no, so it is bronze table. So okay, I don't have bronze table name defined here because I commented this out. It's bronze dot movies, right? So let's use this. See. Okay. So I can also read using, see here, I am reading from the table using SQL. Now I am reading from the table here using Python, PySpark. So how do I read? Everything in Spark, spark.read. Earlier, the same thing we used to read from CSV file. Remember, spark.read dot format CSV we gave. Now we are reading from the table. All that you need to change is just write spark.read.table and then give table name. Again, you will get a data frame. So when you run this, you will say, what is the data type of this, what it has returned? Movies, can see here movies. Movies is a PySpark SQL data frame object. Same thing when you read from CSV, you get a data frame. Same thing you read from the table, you get a data frame. And then the data frame also, you can see here, it has schema. It says this data frame has movie ID, which is an integer. It has a title, which is a string. So this is used when you want to validate here movie ID integer, title string, genre string. To validate the schema, this is useful. Okay. So basically, you can also read from table. You can also read from CSV, JSON, whatever file formats, or using a JDBC, you can read from different databases as well. Once you read data frame, you can also create a temporary view within the within your memory, and then you can also query that from the memory. So there is a movies temp I have created, create or replace temporary view. This is completely in memory. Now I can do SQL on this table just like I do on the database, though it is not there in the database. This is completely in memory, but I can still access and run SQL and do joins, whatever I want to, as if it is a standard table, but it's still in the memory. Replace temporary view. So this view is in memory temporarily. So once you log off, this will not be there. Okay. Now, how do I do the transformations? So extract is done, and then we put it in the raw layer. Now the next step is to transform. So transformations also I can do in two ways. One, I can do using SQL. I can get the data frame and put it as a temporary view and run my transformations as a SQL on that temporary view. Or I can get the movies data frame, same data frame, and then I can write the transformations in the PySpark code. So it has functions to do like filter, select, join, all of that. The syntax you can look up in the Databricks documentation. But basically, it looks very similar to SQL, but only syntax will be different. Again, as always say, don't worry about syntax. You can get it online. You can use AI. It will generate the code. There is in Databricks also, there is here. It's called Databricks Assistant. This is AI assistant that can also create you the code for this. Okay. Maybe it is not enabled in community edition, but in the paid edition, you will have that as well that you can use. So movies ID dot filter, I'm filtering. What am I filtering? Where movie ID is greater than 100. Okay. So once I filter that, all my data set will have only the movies which ID is greater than 100. And from that data frame, I'm selecting movie ID and title. I'm dropping the genre. I'm not selecting the genre. So if I run this original data frame and transformed data frame. Okay, so this is transformed data frame. This is original data frame, correct? So if I run this, what is my original data frame? Movies.data frame. So always remember, any transformation you do on a data frame will always return you a new data frame. The existing data frame does not change. It will still be the same. It's like a new object is created with a copy, and then you are pointed to that object. Okay. So even after I do transformations on this movies data frame, I can still see movies data frame, and then I will also have filter data frame. So if I go here, see, this is my movies data frame, original one, right? So this is what we are displaying here. Second, first we are displaying the transformed. See here, the ID starts with 101 and title. So I have not selected the genre. So genre is not there in this data frame. Now, if I go to original one, do I still have the original? Yes, I do still have the original. I still have the IDs, title, and genres. Okay. So this is the how you can do transformation. This is the transform part of it. Extract and transform. Okay, on this. Now, once you transform, the same thing you can also do using SQL. Remember, I said select movie ID title. I'm not selecting genre from movie stem where movie ID greater than 100. So basically, this is exactly same as writing this. This is writing in PySpark. This is writing in SQL. Once you have registered movies underscore temp as a temporary view. So both are exactly same. They give you the same result. And underlying the processing, the calculation, the processing will be the same for both. If you write in PySpark or if you write in SQL, the same job will run, same process will happen underlying in the engine, processing engine. There is nothing different as part of the processing goes. Only in the when you write it, you can choose to write in either PySpark or in SQL here. Only the syntax will be different. Even when you run
PySpark, when we run it on PySpark, can we do transformation on the movies underscore temp or any temporary table also?
No, that's a table. You need to get it again as a data frame. Okay. So if you run the SQL, you see here underscore SQL df. Again, it will return the results, but it will put these results again into another temporary data frame underscore SQL df. If you want, you can use this in a PySpark code in the subsequent sections and refer to it as this variable underscore SQL df.
Okay, yeah. We can still use that,
But
right?
you cannot directly use this in PySpark, right? It's just a table. Now you have to do spark.read and then table name.
Yeah, correct. I understand that. Yeah.
So it's same thing. So most of the people are comfortable writing in SQL. So what they do is all you have to do is just register it as a temporary view. Just write one line like this, and then you are good. Then you can write everything in SQL like this. Or if the calculations are complex, you don't want to write complex SQL, then you can write in PySpark also. And then you can chain, you can do one transformation at a time. You don't have to do all transformations in one line. You can do one transformation, you get a data frame, take that data frame, and then you can write more transformations on that. Okay. So you can do here filter df1 is this one. Now I can do filter df. Filter df2 equal to filter df1 dot select. This is also completely acceptable. So once you do this filter the ID greater than 100, you get a data frame called filter df1, which has movies greater than 100. Then you are using that data frame, now selecting only 2. So if you see here df1, then you can see df2, what it has. You can check this. So this is df1. ID is greater than 100, like I have written this here. But it still has all 3 columns. Next, I'm using this data frame and selecting only 2 columns. That is filter df2. So if I go to filter df2, so this is filter df2. Now the third column is not. So this is also perfectly fine. You can write that as well. Okay. Let's make this filter so that we don't. All right. So those are the transformations. I'll take another 5-10 minutes to wrap this up. Then I will publish this. You can do your own hands on all the files and the notebook. You can keep running different things. We will collaborate online. So that's the part here. Movie ID greater than 100. So you have this filter df2 data frame, right? So what I will do, I will just write this filter df to a new table in the silver layer. Okay. We have done till this, right? So I don't want to go to ratings, another table. This is for the join stuff. So I will do filter df dot right dot format data dot mode overwrite format dot save as table, and then I will try. I want to write to silver, right? Silver dot. So what is the table name? I will just write movies 101. Okay, just to say that this is filtered data which has movies greater than 100. So I'll just run this. Okay. Now I can go here, write %SQL, select star from silver dot movies underscore 101. Correct? Okay. So it has starting from 101 and it does not have genre. All right. Any questions? I will stop here. I will publish this notebook. I have shown you how to import. If you have any questions, you can come back to me. I will show you how to import this in your environment. I will also give you where is the source file for this. And I have shown you how to import that file into that folder, whichever folder you are doing. So then we can continue. I want you to practice until here, until writing to silver. Then we will continue in our next class, more transformations and aggregations that we want to do, and then we will have some assignment as well at the end of all of these transformations. Okay, all of this. So for now, go until silver 101, movies 101. So ratings we will come later. Is that good?
Yeah, good. Harun.
Okay. Everybody comfortable? Of course, we will again review
Yes.
this in our next class. And then we will go through. Yes, Ramya?
Yes, Arun.
Okay. All right.
So the filter
thank you
data
so much.
frames, we can create that object on multiple tables also, right? Harun?
Yeah. You can
While
create
transformation.
any
Okay,
number of tables.
tables.
You can just
Any number of
change
tables.
whatever transformations you want. You get a new data frame, and then you can write that data frame as a new table. Okay. Just keep an eye on what transformations you are doing, what data frame you are getting out, and what data frame you are using to write. That's it. Okay. All right, guys. Thank you so much. Taken 10 minutes more. I think we are good. So next week, I promise there won't be any theory concepts. We will directly jump into more code, write more transformations, then write aggregations, and we'll try to wrap up the batch processing. And we'll do a lot of hands-on practice and assignment on this, because this is the core to get into the data engineering part. Okay, all good?
Okay, Arun. Yeah, all good.
Practice and communicate in the group. I will be there to help. Pawan will also be there to help. Please reach out. 10-15 minutes, you can directly connect with me or Pawan. If you have any errors, we can work on that and we can fix and get you moving. Please communicate in the group. Okay. I will try to get all these details by end of day today. The recording and the notebook and the source files and everything. All right.
All right. Yeah.
All right, guys. Take care. Have a good day. Have the rest of weekend. Take care.
You too. Thank you.
Thank you, Arun.
You too. Thank you. Bye.